Hi folks, this is Calc 1 Quiz 17. Number 1. We're told the velocity of an object along the y-axis in meters per second is given by this function, where t is the number of seconds after the start of the motion. So in part A, we're asked to find and interpret v of 0. So, to find v of 0, everywhere I see a t here, I replace it with 0. That gives me -1. What's that mean in this instance? Well, as we discussed in class, if we're moving along the y-axis, I'm starting at some point along the y-axis, so I'm moving vertically up and down. And for us, the up is the positive direction, down is the negative direction. So I'm starting at some point. I don't know where. That'll get answered in part D. But I'm starting at some point along the y-axis, and the velocity is -1. So that tells me, the negative tells me I'm moving downward. Now in this particular case, we're told meters per second. So this means that the object is initially, because we're at time equals 0, heading downward at a rate of 1 meter per second. So that'll do it for part A. For part B now, we're asked to find and interpret this definite integral. So the integral from 0 to 2, v of t dt, is the integral from 0 to 2 of that function, 3t squared minus 2t minus 1 dt. So we go back, and instead of using the limit process, we can use the fundamental theorem of calculus. The integral from a to b, f of t dt, is big F of t from t equals a to t equals b, which is f of b minus f of a, where f is any antiderivative of little f. Antiderivative means, remember, that big F prime of t is the same as little f of t. Now, the properties of the antiderivative, the basic properties, are inherited from the properties of derivatives. So in particular, the sum and difference rule for derivative gives us a sum and difference rule for antiderivatives. So to find an antiderivative of 3t squared minus 2t minus 1, I just need to find an antiderivative for each of these terms and then subtract them accordingly. The major formula we have for antiderivatives at this point is the power rule formula. Integrating u to the n du. We do the opposite of the power rule we did for derivatives. So instead of subtracting the power on the exponent, we add 1 to the exponent, and then we divide by the new exponent. Of course, as we mentioned in class, this isn't going to work if n equals -1. Alright, so with those two facts, the integral of 3t squared, the 3 is a constant, and the constant multiple rule says that goes along for the ride. So it's going to be just 3 times t to the 2 plus 1, 3, over 2 plus 1, 3, minus 2 times, that's t to the first, t to the 1 plus 1 is t squared over 2, minus, and an antiderivative of 1, you can think t to the 0, even though there might be issues at 0 itself, that's just going to be t to the first power. I'm going to evaluate this from t equals 0 to t equals 2. I can simplify this just a bit, and I get t cubed minus t squared minus t We're going from t equals 0 to t equals 2. So I plug in the t equals 2 and subtract off what I get when I plug in the 0. So we're plugging this into the antiderivative. And when the dust settles, I get 8 minus 4 minus 2, which gives me 2. So that tells me what that integral is. Now I've got to figure out what that integral means. Okay, so we've found the value of this integral is 2. What's that mean in this situation? Well, remember back to the whole setup here. If s of t denotes the position at time t, I get the velocity by taking the derivative of the position. And so when I integrate from a to b v of t dt, I'm integrating from a to b the derivative of the position function. Now, using the fundamental theorem of calculus, I can pick any antiderivative I want for this. So the antiderivative I can pick for s prime of t is just s of t. So this is s of b minus s of a. Now this might not be the same antiderivative I actually used to get this number, but remember any antiderivative works. We'll actually recover what the actual value of this is here in part D. Okay, but looking at this abstractly gives us an indication as to what this means. This is the difference in the position at time B minus the minus the position at time A. And this, remember, is what we call the displacement. Okay? So this is the displacement of the object from t equals 0 to t equals 2. So wherever it starts initially, 2 seconds later we have a positive displacement of 2. Since we're moving along the y-axis, a positive displacement means I'm 2 units above where I used to be. So putting this all together, we can say 2 seconds after the motion begins, the object is 2 what? Meters above where it started. So that'll do it then for part B.